Hello, welcome back to the Cognitive Whiteboard. My name's Jim, and today we're going to be talking about virtual metering and time travel. In other words, where we're going, we don't need well tests. Now, to start off with this, I'm going to talk a little bit about the sort of measurements we might have in our well. We might not have all of these, we might even have very few of them, but this is basically a way that we can make use of these measurements in a way to tell us what's happening in the well. So for instance, I've got an ESP well here, so I might have pressure readings around the pump itself, a wellhead pressure reading, and I'm then going to have certain assumptions about the fluid that is passing through that well and also the reservoir itself. So I will have an estimate of water cut, GOR, the oil density, API, and also what the reservoir pressure is. Those are not things that we would typically measure in ongoing operation, but we'd have an understanding of what we might expect them to be. Now, based upon all these various measurements, I can then calculate a rate through the well. And the traditional method of doing this, and the one that is the most common, is a VLP-IPR intersection. Okay, so based upon the fluid properties and what I understand the reservoir pressure to be and the wellhead pressure, I can then calculate those two curves, and the intersection will give me my liquid rate. But that's just one way of calculating the rate. If I have any of these other measurements, I can introduce other methods. So for instance, if I have the DP across the pump, then I can use the pump calculation to determine what that should be. If I've got a choke and I have a measurement of the flow line pressure and the wellhead pressure, those two measurements can be taken in order to produce the choke rate. And all these different methods will have sets of physics that overlap and are independent, and they're all based on the idea of what the fluid properties are, what my water cut is, what the GOR is, and so forth. So if they disagree, I can then use that to determine what might have actually changed. So if they diverge over time, then that can tell us something. Because if we've got everything correct, reservoir pressure, water cut, everything, then they will agree perfectly. And that tells us that that is the correct rate. However, when they start to diverge, they'll do it in different ways depending on what has changed. Now what that will allow us to do is to actually fire up the oil field equivalent of a flux capacitor and travel back in time and see what changed at that point. Because for instance, if the water cut goes up, then the choke will respond differently to the reservoir. And the choke has very little interaction with the reservoir. Those sets of physics are largely independent. So dependent on how they start to diverge, we can then use that to interpret what's happened. In other words, we can go back in time and basically pretend that we did a well test. We can determine what the fluid properties are without needing to intervene directly in the well. So what I'm saying is virtual metering, which is basically what this technology is called, can then be used to help us understand what's happening in the well, even if we have less data, if we don't have the data point of a well test. So we can do that, determine what's going on. We can even use that as part of our future prediction. If the reservoir pressure is going down, that's a trend that might continue. Same with the water cut. And of course, we might see an interaction between these different things that are going on, and that will be reflected in the data that we have. If we don't have all of it, we can maybe be less certain, but we can still home in on a rough answer of what we expect to be happening. So that'll be an ongoing theme in these whiteboards, making better use of our data and seeing what we can get from it if it's particularly sparse. So I hope that's been useful. I hope to see you back at the Cognitive Whiteboard soon, but until then, take care.